Hello. The world of R is particularly rich in the area of statistical analysis. In this video, I'm taking the opportunity to introduce a sampling, and I very much stress that it is only a very small sampling, of ways in which R can be used for statistical analysis. An easy way to start is with the summary command. Applying the summary command to a data object will generate the quantiles for all quantitative data fields, including minimum values, first quartile values, median values, mean values, third quartile values, and maximum values. If you only want to examine the quantiles for specific fields within a data object, use the quantile command. Unless you indicate otherwise, it will default to the same breakpoints as the summary command. However, by using the probs argument within quantile, you can specify the breakpoints you want to see. In the second example using the quantile command, the quantile breakpoints are defined using the seq sequence command to range from 0 to 1 at increments of 0.1. The quantile command is just one of a huge number of statistical functions available in the stats library. There is absolutely no way that I could explain them all in this video, so I have included a command in the sample code in the source pane that will list all of the possibilities contained within this library. Just type library followed in parentheses by help equals stats with stats in double quotes. In both examples for the quantile command, I set the na.rm argument to true to ignore any data records for which no value has been provided. At this point, let's use the view command to get a feel for the paper airplane tests data set. As you can see, the dataset contains one row for each of 15 people that took part in the tests. For each person, flight distances are recorded for, respectively, large and small paper airplanes. Now that we know what the data looks like, let's do a t-test using, of course, the t.test command, which once again is from the stats library. For each of the two t-test examples, we start by specifying the two data fields that are being compared. The data for the large paper airplanes and the data for the small paper airplanes. Since the first t-test example is for a paired test, we include an argument stating that paired equals true, as well as one specifying a confidence interval of 0.95. For the second t-test example, which is for an independent t-test, we include an argument specifying that var.equal equals true, meaning that variance will be calculated by pooling the data from the two columns in paper airplane tests. To wrap things up for this video, we'll do a Pearson correlations test. The command for this, which can also be used for other types of correlation tests, is core.test. Arguments for this example include the two groups of data being compared, which once again are the large airplane and small airplane data. Alternative, which indicates the alternative hypothesis, or in this case, hypotheses to be used. The correlation method, which in this case is Pearson. And the confidence level. As I mentioned before, this just scratches the surface of the types of statistical analysis you can do using R. I encourage you to consult the R documentation for further information regarding the possibilities in this area. In the next video, I'll introduce you to some ways in which you can easily plot data in R.